All right. Find the radius and height of the right circular cylinder of largest volume that can be inscribed in a right circular cone with a radius of 6 inches and a height of 10 inches. So I've got a cylinder that's inscribed inside of this shape, kind of like how we did with the rectangle inside of a triangle. But now we're working with 3 dimensions, make it a little more difficult. Okay. All right. We're going to have to start using this stuff here in a second. Okay. All right. So we want to find a radius and height. Largest volume of the right circular cylinder of largest volume. Okay, so then what's going to be our primary equation that we're working with? Volume of. Okay, you guys remember what that is? Right. So area of the base times our height. Okay. All right. And then it's inscribed inside of a right circular cone with a radius of 6 inches and a height of 10 inches. So of this cone, we've got radius of 6 inches, and then my height is going to be 10 inches, and that's the height of my cone. Okay. All right. We want to come up with an expression or we want to come up with some sort of volume formula, okay? But it's in terms of 2 variables here, both radius and height. So if I go to take the derivative of this, I have 2 different variables. I need to get it as a function in terms of 1 variable in order for me to find this derivative, okay? Bless you. Now, which variable do you think would be easiest to solve for? Not necessarily solve for, but to plug in. Where would you rather plug something in? Would you rather plug h, right? So if I ideally can come up with an expression for h, then that's going to be very beneficial for us, okay? And remember, this is of the cylinder, okay? So I tossed a hint in there just to kind of get us started, and we want to use the cross section, okay? So imagine that I slice this cone straight down the center along with the cylinder as well too. What that would look like is something along the lines of this. All right. So we've got, that's like the cross section of our cone. And then we would have our cylinder that's inside of it as well too, kind of here. So like cone is, say this is our cylinder here. And then our cone would be the rest of it. Okay. All right. So then what I want to do is I want to start putting some of my values in there so I can try to figure out, what my radius is going to be and what my height is going to be. I need to know what my radius is. And ideally, I need to know what the height of that is as well too, or at least come up with some sort of way that I can relate those values together. Okay. Now, I know that the height of my cone is 10 inches. Okay. So the height of this whole guy is 10 inches, and the radius is 5 inches, okay? 6 inches, sorry. It'd be too easy if it was 5. 6 inches, okay? All right. Now, this line right here can be represented as such. Or as how, I guess I should ask. Like, if I have that this point right here is R, the other way that you can think about this is you can think about it as like an X value. And if this is an X value, then the height of this, which is what I would want to find, is kind of like a Y value. But it's a Y value on this line right here. So you can think about it like a line, okay? So if I can come up with an equation for this line, then I should be able to come up with a height that I can use to plug into my volume formula. Okay? So, really the only thing that we can do is imagine bounding it to a set of axes and then coming up with an equation for what this line would be. It's almost like, okay, so like that problem that the ladies put on the board, or like, I'm trying to think of like, we've done one like this in the past where like, I mean, even if you had like a rectangle that's inside of a triangle, right? And I can imagine this coordinate point as x, y. So if I leave this as x, if I can come up with an expression for y, then I know like a point that I can use, okay? I mean, it's kind of similar to this situation, but I'm not going to use, in this case, I'm not going to use like similar right triangles. I'm going to try to use like an equation instead, okay? If this is a height of 10, what's this y-intercept? 0 to 10. And then this would be what? Okay. So then what would be an equation of a line that passes through those points? So if I have 0, 10, and then 6, 0, what we could do is we can come up with an equation of a line, passes through those points, and then go from there. Okay, so our y-intercept is 10. What would our rate of change be? What would our slope be? Negative 5/3, right? Because I would have y equals negative, and then you could do 10 over 6 x plus 10, or like you guys said, negative 5/3 x plus 10, okay? What that gives me right here is that gives me a height, which is like a y value, okay? So instead of having like a height of y, it's just a point on that equation of that line, which that's the equation of the line, is negative 5/3 x plus 10. So this point right here would be r, and then instead of using x, we could have negative 5/3 r plus 10. So this represents my radius, and then this represents my height. What's my height going to be? Or what my height is going to be. Okay? All right, so then now what I can do is I can plug that in to my value for my height and then take the derivative. Okay? Because that's what my height of my cylinder is going to be that's inscribed inside of my cone. All right? So then I would have volume. It's a tough one. Pi, and then r squared. Yeah. And then times my height, which we said is negative 5/3 r plus 10. And now everything is in terms of r, which is what our goal is. I can't help but wonder if we could do this using right triangles. I didn't really try thinking about it that way, but like similar right triangles. I imagine we probably could, but I'm not exactly sure how that would work out. All right, so now we multiply everything out. We take our derivative. All right, so pi r squared times negative 5/3 pi is going to give me negative 5/3 pi r cubed, and then plus 10 pi r squared. And I'm confident that at this point, you guys can take the derivative, set it equal to 0, and find your value. It's just the toughest part is leading up to that point. So leading up to the point where, okay, use the cross-section, but then like how do I come up with an expression for the height in terms of my radius? I've got to relate that relationship together. It's bounded within there, so I have to use that as my limiting factor. We okay?
What would the domain be?
It's a great question. What's the most my radius can be? 6, right? So that's like the most that it can be, like here. So then what value would I, well, it would just be 6, right? It would have to be between 0 and 6. So let's set that off to the side, because we need that. Glad you brought that up. So R is an element of, we don't want it to be 0, we don't want it to be 6, so 0 to 6, okay? Well, I mean, I guess we could think about it as 0 and 6. I'll put some brackets there because we can test with those numbers anyway. All right, so now we're ready to take our derivative, v prime. All right, so negative 5 pi r squared plus 20 pi r. And then we need to set that equal to 0 and see what we get. I would factor, so then you could factor out negative 5 pi r, and you're left with r minus 4. Yeah, okay. But at least it ends up solving nicely. So negative 5 pi r equals 0, and r minus 4 equals 0. So I get that r equals 0 and r equals 4. So our optimum situation is that my radius is going to be 4. Let's find out what that volume is going to be. So I should test v of 0, v of 4, and v of 6. But I know for 0 and for 6, I end up with values of 0. Okay? Because if you do plug in 6, negative 5/3 times 6 is going to give you negative 10. Negative 10 plus 10 gives us 0. Okay? All right, so then when I plug in 4, I would have negative 5/3 pi times 4 cubed plus 10 pi times 4 squared. All right, so 4 cubed is going to give me 64. And then multiplied by 5. So 3 doesn't go into either one of those. So 64 times 5 is going to give me 320. Yep, so negative 320 pi over 3. Okay. Plus, and then, so 160 pi. Okay. And then if I find a common denominator, it would be negative 320 pi, and then 3 times 160 gives us 480. So the difference between 480 and 320 is going to give me 160 pi over 3. Yep. Okay. And then my unit of measure was inches, so inches cubed. So we have a maximum volume of 160 pi over 3 inches cubed when r equals 4. Okay. All right, questions there? All right. Okay, what do we got next? A liquid form of penicillin manufactured by a pharmaceutical company is sold in bulk at a price of $200 per unit. If the total production cost in dollars for X units is C of X equals 500,000 plus 80X plus 0.003X squared, and if the production capacity of the firm is at most 30,000 units in a specified time, how many units of penicillin must be manufactured and sold in that time in order to maximize our profit? Okay? All right. It's a lot. Obviously, we're going to need this equation here. Other important things, $200 per unit when we are selling it in bulk. That's the cost. And then our capacity is at most 30,000 units. So that's some domain stuff right there, right? That gives us the most that we can actually produce, okay? All right, what do we want to maximize? Profit. What is our equation for profit? Just a general equation for profit. Yeah, or you could think about like revenue minus cost, either way, sales minus cost. So, all right, so that's what we want to maximize. We want to maximize our profit. So we got to come up with expressions for all of those things. Okay? All right, so they give us a bunch of information in the question itself. They give us what the cost is, which is super kind of them. But now we need to come up with an expression for our revenue. Okay? All right, so We're selling it in bulk at a price of $200 per unit, okay? And then they give us the cost. All right, well, that actually makes it pretty easy. What's going to be our revenue? 200x. Minus my cost, so 500,000 plus 80x plus 0.003 x squared. All right, there we go. Revenue minus cost. All right, domain. We can make 0 all the way up to, was it 30,000, right? Okay. All right. You might be asking yourself, if they want to make more money, why don't they just make the maximum amount of pills? Well, let's see what happens when we do that, okay? All right, so let's just take just a second to simplify everything. So negative 0.003 x squared. And then 200 minus 80 is going to give me plus 120 x, and then minus 500,000. Okay, now we're ready to differentiate. So I'm just going to put capital P prime, indicating that is the derivative of our profit. And then we take the derivative. Nope, not x squared, x. All right, so negative 0.006x plus 120, set that equal to 0. What's 120 divided by 0.006? 20,000. Good. All right, that gave me my candidate. So now I want to test P of 0, P of 20,000, and P of 30,000. Okay, if I plug in 0, what do I get? That's not good. That's not what we want for our profit, right? Okay, so that's not the way. All right, so then let's plug in 20,000 and then 30,000 and see what we get. I don't think this is going to end kindly. Maybe when we plug in 30,000, but not when we plug in 20,000. So I'm just going to do it. I'm just busting out the calculator now. Boop. Okay, so negative 0.003 times 20, 1, 2, 3, quantity squared plus 120 times 20,000, and then minus, I need another 0, I think. That sounds good. 700,000? It's not a bad profit, you know? Oh, wait, that's for 20,000. Might be. All right, let's change those values to 30,000 instead. Ooh, I only get 400,000. How many pills am I making? 20,000. Yep, good. So we would have a max profit of 700,000 when we produce 20,000 pills. Okay. All right. Doing okay? I think in comparison, that was one of the simpler ones for sure. All right. A closed cylindrical can is to hold 1 liter of liquid. How should we choose the height and radius to minimize the amount of material needed to manufacture the can? What's giving you the angs? Is it the shapes or what? It is indeed the surface area. Anytime they talk about material, of like some sort of packaging, it's going to be, like Arthur said, the surface area of that shape that we're dealing with. So, all right. Surface area of what? Cylinder, yeah? Okay. Yeah. So surface area, you got to think about it's what it's consisted of. 2 circles and then a rectangle, right? So 2 pi r squared plus, and then the area of the label, essentially, around the can. So it's the circumference times our height. So what'd you guys say, 2 pi rh? Yeah. Okay, cool. All right. We need to figure out how we choose the height and the radius to minimize that amount of material. Okay. Now, what's the other equation that we're working with? Okay, so this is our primary equation. I'm going to star that. Volume, because we're talking about how much it holds, and our unit of measure is cubes, so it's another indicator that we're working with volume, which is what? Pi r squared times h. However, we know one of those values. What value do we know? The volume. All right, so 1,000 centimeters cubed, okay? All right. We need to solve for a variable and then plug that variable into our primary equation. Probably h. There's only one instance of it in our primary equation, and it's not squared. H is the way to go. So then h is going to be equal to 1,000 divided by pi r squared. So now we need to take that and plug that into our surface area equation that you guys are so very excited about, and then we'll do the thing. 2 pi r squared plus 2 pi r times my h, which is 1,000 divided by pi h squared. What's happening right now?
We hope.
I'm glad you guys remembered that.
No, it's been someone else. It's worse.
Oh,
Wasn't it Laney? It was someone like that.
Oh, man.
Oh, no. Okay.
Let's find out! It started with guitar, so you know I'm not mad about that. Hey, let's do it. Actually, this song's a banger, so. Okay, here we go. Hey, fortunately, at least my R's cancel out, right? It doesn't fully cancel out, but I get rid of one instance of it. Okay, my pi's cancel out as well too. So then I would have 2,000 over R. Is that the theme for tonight's game? Who do you guys have tonight? All right, so now we want to take our derivative and set it equal to 0, yeah? So I thought about 2,000 over r is 2,000 r to the negative first. So then negative 2,000 over r squared. So I'm going to set that equal to 0. 4 pi r equals that. And then let's do some multiplication. So 4 pi r cubed equals 2,000. Divide. So r cubed equals 2,000. No. What's 2,000 divided by 4? 500. Over pi. What's that? Sorry. Divided by 4 pi. It was coming. All right, so cube root. All right, so now we know what r is. So now we can plug that back into our surface area. I'm distracted by the music. What do we want to do? We want to... Oh, we need to figure out our height, right? Yeah, so it wants to know what both radius and height are, so... Okay, so I need to plug that all the way in up here. Cube root of 500 over pi. Sorry, I literally thought I was being shushed. Oh, man.
This is no, there's no way. See, at least they're switching the song and made it pretty sad.
That's almost making me upset. It's like when you're like trying to watch TV with someone and they're just like flipping through the channels. Like, it almost makes it worse.
So I remember like the first week that they did it, she kept the intro going for like all the 3 minutes. All these songs are like extremely simple.
Man. Whew. Okay. All right. Yes. Okay. I mean, guys. Okay. Is there much that I can do to simplify that denominator? Let's see. We're raising it to the 2/3 power, right? So pi, and then 500 over pi to the 2/3. So we can simplify this a little bit. I don't know how far it's really going to get us. But you have a pi being multiplied by pi to the negative 2/3, which is just going to give us a pi to the 1/3, or cubed root of pi. And then times 500 to the 2/3, or, you know, the cubed root of 500 squared. So if you square 500... 25,000, right? Did I add an extra 0? It is, okay, it is 250,000. Okay. All right, so I mean, if we really want to, 1,000 divided by the cubed root of 250,000 pi inside of that cube root. But, you know, it's not going to get much nicer simplifying that, I don't think. I mean, if we do the cubed root of that, we could pop a number out and reduce it with the 1,000, right? So, like,
I think we're alright.
you guys cool? Are we good? Yeah. Hey, what's our unit of measure? Can we at least put that on there? Centimeters? All right. Okay. That's fine. I feel as if I should take the cube root of 1,000 and... All right, fine. Okay, fine. All right. Now, we should find out what our volume is. We'd multiply those, or we'd plug that in for our radius and our height, and I don't think we're going to get a pretty number, are we? Volume equals pi r squared times height. We came up with an expression for r. We came up with an expression for h. Oh yeah, it would equal 1,000. That is what my volume is. Its surface area is what we want to maximize, right? So we'd have to plug it into the other equation. I'm not going to do that. Yeah.
They didn't have the 6 set up. Yeah.
Yeah. All right. Questions there? Okay.
What do we do differently for maximizing something versus minimizing?
That's a good question. So you run into a couple of situations, right? If the process does not change, Ashley. What needs to change is when you check your candidates of values, right? So like in the last problem, we made a list of like, okay, here's my values. My absolute max would be the highest. My absolute min would be the lowest. A lot of these problems lend themselves to only giving you one realistic critical number. Usually you're checking like the endpoints of your intervals, which oftentimes is not what you want, but the more exciting value is the single value that you end up solving for that falls in the domain. Now, if you get more than one value when you're solving for R or X or whatever it is, then you need to make sure that you pay close attention to how you come across that value and testing it to see, is this actually the value that I want? Is this the value that's giving me the absolute max, or is it the other value that I ended up with that's giving me the absolute max? But usually you'll end up with one value. Like when we solved for R here, we had one value, and that was the value that we cared about. Does that make sense? But the process can't change because you're taking the derivative and setting it equal to 0, no matter if you're finding the min or you're finding the max. So, okay. That's a lot of words, guys. An offshore well is located at a point W that is 5 kilometers from the closest point A on the shoreline. Oil is to be piped from W to some point B on the shore that is 8 kilometers from A. The oil will be piped in a straight line underwater from W to some point P between A and B, and then on to B via PIP along the shoreline. Forgot an E there. If the cost of laying pipe is $1 million per kilometer underwater and $500,000 a kilometer over land, where should the point P be located in order to minimize the cost of laying down the pipe? Should I have reworded that?
100%. Yeah.
If it's still a test, I'm
Well,
just
let's
taking
This is a math lesson.
All right. Well,
Let's just do it tomorrow on the side of it.
oh no, we're doing it now for sure. For sure. Tarun is right. I mean, we got to make a diagram. That's it. We've got to make a diagram. Okay. All right. So offshore well is located at a point W that is 5 kilometers from a point A on the shoreline. Let's start there. So A on the shoreline, W is our well. Okay. 5 kilometers. Toss that bad Larry in there. All right. Oil is to be piped from W to some point B on the shoreline that is 8 kilometers from A. All right. So B is here. This is our final destination, is to end up at B. Okay. What did it say? 8 kilometers from A. So then this is 8 kilometers. Okay. All right, the oil will be piped in a straight line underwater. Okay, so from W to some point P between A and B. Let's just say it's here. Doesn't necessarily have to be halfway between, but it's got to be somewhere between the two. Okay, it just says that it's between A and B, and then on to B via PIP along the shoreline. Okay, so oil is going from W to P, and then from P to B. Okay? All right, Tarun, there's your diagram. All right, if the cost of putting pipe underwater is $1 million a kilometer, and then $500,000 a kilometer over land, where should the point P be in order to minimize the cost of... Yeah, okay. All right, so, we have a rate, like we have a cost, we just need to come up with our distance, right?
It's the bridge thing that we did. What is the bridge thing, Arthur? I don't know. We did this with a bridge before.
We need a variable somewhere, aside from just letters. X where? I think we should do it with respect to A instead of B. I don't think it would make a difference. Ashley, you could probably do it either way. But here's why. I'm going to put it here. I'm going to put X right there because I need to use this part of the triangle from like here to here. So it would be helpful if I defined this length as X, okay? Now, if I know that that's X, now I can come up with an expression for the length of W to P. And how do I figure out that expression? Yeah, where's that come from? What's that using? Yeah. Good old Pythagoras taught us a theorem that allowed us to find the length of any one of our segments of our right triangle. If we have the other two sides, I have the other two sides, so I can come up with an expression for that. So, square root of what? Oh, plus. Sorry. All right. So x squared plus 25, 25 plus x squared, whatever you guys want, it doesn't really matter. Okay. And then what is this length going to be? Great job. Okay. So now, what do I want to do? Minimize the cost. I need an expression for cost. Whew. Cost is, what is the cost of constructing a pipeline underwater? $1 million, right? Okay, so $1 million. A kilometer. What's our distance? Well, underwater. Square root of 25 plus x squared, right? That's my distance.
Because we threw it.
So we said this was shoreline here, right? This is our point that the well is at out in the water. So that's out in the water, okay? Plus, now I need the cost of constructing a pipeline from P to B, which is 500,000 times what? There we go. Okay, whew, we did it. In my opinion, we did it because that's the hard part, right? But, yeah, you're right. We do have to take the derivative. That's exactly what you guys said. So we should do that next, okay? All right, so this is going to require chain rule. So square root of 25 plus x squared. So that would be 500,000 times 25 minus or plus x squared. Why do I want to keep making minus happen? To the negative 1/2. And then multiplied by the derivative of 2x. Sorry, I took the 1/2 times a million, or I just did that right from the rib, which I feel like is dumb because now I'm multiplying it by 2x, right? So I should have just canceled the 1/2 and the 2. Just got a little ambitious. Okay, and then 500,000 times 8 is going to give me, yes. Good. Now I got to set that equal to 0. Oh, yeah, sorry. I don't need that. It's the derivative. Yeah, I forgot. Halfway through, I forgot that we were taking the derivative. So 500,000 times 8, which is going to be 4 million, you're right, but the derivative of that is 0. Okay, and then it would actually not be 500 minus 500,000. Yeah, so I don't need that x there because I'm taking the derivative. Sorry about that. Okay, well then that makes it way more attainable, you know? So then minus 500,000. All right, I should have taken a step where I simplified it first. Okay, so then let's simplify this, right? Are we good? Did I do something else wrong? Are we good? Okay, all right. So then let's change that 500,000 to 1 million. That x is up there as well too. Over square root of 25 plus x squared. And then I'm actually going to, no, whatever, minus 500,000. Move it to the other side. There it is. Okay. All right, so let's multiply both sides by square root of 25 plus x squared. No, not 5 million. Oh my gosh. Plus x squared equals 1,000,000 x. Divide. So when I divide by 1,000,000, then I get a half. Or, you know, I could divide by 500,000 to get square root of 25 plus x squared equals 2x. Okay, I still got to get x by itself, so I should square both sides. 20. All right, I'm getting there. I'm getting to a convenient place. Equals 4x squared. And then subtract. Set it equal to 0. So 3x squared minus 25. If I subtract both pieces to the right. So then I would get x equals, whatever, x squared, 3x squared equals 25. Let's just take our time. X squared equals 25 over 3. And then we would get plus or minus the square root of 25 over 3. But really, the only value we want out of that would be positive. And we would have 5 square root of 3 over 3. Yeah? Yeah? Okay. All right. So then we want to find, that's our x-coordinate, right? Okay. And then we would want to find what the cost of constructing that pipeline would be. So then we should plug that into our original equation and find what the cost is. But I think we get where that's going, right? We good? Okay. Okay. Your homework is on day 2. It's still listed there. I'm going to pass out your chapter review for you guys as well, too.